Okay, then let's just shove this back into 3D for the moment. And you're all aware now why we've got this other icon up there. I think we've told everybody, but I'll use the original one just for simplicity for the moment. So let's just shove that back into the slicer, because I just want to spend a couple of minutes on the slicer side of it, just to pass on a couple of tips that some of you may know and some of you may not be aware of. So as Malcolm says, the way it goes into the slicer, I don't care. It really doesn't make any difference, because that's there, but I'm never going to slice it in the way it goes in anyway. Now that this particular box, the way it is, complete with hinge this time, I would want to print this on the flat. So in Prusa Slicer, and I'm sure it's the same in all the others, I would click on this box here, that's rotate. I don't need to bother rotating it. I'm not interested. Click on that one, and that's it, flat on the desk. Now if I want to rotate it now, I can do. You can rotate it to make it tidy if you want to. It's entirely up to you. And that's it, ready for printing. And then you slice it and whatever your slicer does. So the way it goes into the slicer really is immaterial, and it will go in the way I've drawn it. In what I mean, I probably didn't use the same X, Y, and Z axis as Malcolm did. But when it's in the slicer, you orientate it for what you want. The other thing it does is puts it in the center of the plane, and quite often I'll say no. I'll move it there. And you might say, well, why would I move it there? Well, for the simple reason, the bulk of the stuff that I print doesn't cover the entire bed. So I want the bed to have some even wear. So every now and again, I'll print it up here, or maybe across there, or this side. If I keep doing in the middle all the time, the plate starts to get a bit worn, and I just want to use the bed all round. It's as simple as that, really. And the other thing is, with a lot of beds, I found I've been doing a new mimic panel for myself, which took my bed to its limit. In fact, I had to do it in 2 halves and glue it together. But what I also found is that the mimic panel was bigger than this, and I found the mimic panel was better lying that way than that way, because I found up this top edge here and along this bottom edge, the heating element faded off a bit, and my print wasn't sticking very well. So, don't be afraid to experiment with different parts of your bed. It should be even all over, but it tends not to be. So moving on to one or two slicer issues, because we chatted with Malcolm as well, because he had the string in. And we talked about that, but we also went to talk on about the settings, which is an area that I'm one of these people that if it works, I leave it alone. I'm one of these people that think the more you fiddle, the more chance of it going wrong. And a lot of people have spent a lot of time giving you print settings. And this applies with filament or with resin. With resin, the resin printers have produced lots of profiles, and you've got a lot of profiles with the filaments, and they know what they're doing. So I tend not to fiddle that much. But one area where I do is in the print settings, or the filament settings, sorry. If I go into the filament settings, you see here, I ensure, now I use Sunlu filament. And on the side of all filament you buy, there will be a temperature range, and what it says on the front of the Sunlu one is 205 to 215. So I tend to do my first layer at 210 and the second layer at 200. And I learnt in the very early days, because like many I thought 10 degrees, that's neither here nor there, that won't make a difference. I soon learnt 2 or 3 degrees can make a difference. So, don't think you've got to change it by 20 and 30. Now, the way I changed these was with a trial that I'll show you in a moment, is that the first layer needs to go down a little bit hotter so that it adheres to the plate. Now, if it's too hot, it gets too squishy and gets in a mess. If it's too low, it won't stick to the plate. Now, that temperature obviously will vary depending upon whether you're heating a bed. I normally have my bed heated to 60 degrees, as you can see here. Different printers, different beds could affect the first layer you put down. But the secret is to get that first layer down. Then you can drop the temperature down 5 or 10 degrees to get the other layers. So what I want to look at quickly is that first layer. Now, those with Prusa printers can probably go to sleep during this next bit because they probably already done it. And I don't know about other slicers or printers, or other printers, whether they're capable of doing it. So let me go back to my PowerPoint. There. Whoops, go into presentation mode. Okay. Now this is what the Prusa will allow me to do. It's built in, and it's for calibration of the first layer, the Z layer, and it prints this pattern. Now, I did try doing a fusion diagram of this, but the problem is I didn't know how wide to make the actual lines. They basically need to be just one nozzle thickness. So what the Prusa does, it prints this pattern out, and then it prints this one here, which is a series of lines. The idea being is that when it's finished, this pad here should be a pad where you can see the lines, but you haven't got any gaps between the lines or humps. And you can see what Prusa tell you is this is adjusting the Z. Totally flat, they don't advise. That they don't advise. That obviously they don't advise because it's just not going to stick. What they advise is a shape like that. Now, that looks easy. But if you peel a bit off, it's not so easy to see the cross section, even with a good magnifier, because it's so small. So what I do with the Prusa, as I say, I don't know whether it's available on other printers or not. As it's printing this shape, you can adjust in real time that Z difference. So you can see whether the first line goes through, and I tend to just flick it with my finger to make sure it's sticking. And you to dial the Z down to bring it closer or further away until you've got a good stick. Then of course you can do another one. This particular test takes about, well, less than 2 minutes really, and that way you can get the Z starting point for the first layer really good. And that's what I think, that and the temperature is the one to get that first layer to stick properly. Now I can't speak for other printers. I don't know how they work, because the Prusa, as those who know, when it starts off, it will visit 9 points, 3, 3 and 3, and it adjusts. It doesn't adjust the bed, it adjusts its software. So the software compensates for an uneven bed or a bed that's on an angle, because the bed is fixed. It's actually very, very good. It very rarely lets you down. And what it is, there's a sensor built in here which senses where the bed is, and if they tell you if you have to adjust the Z by more than about 0.2, this is going up to 0.6. It's for illustration, but no, I'd like to see it 2 microns, I think, or 20. No. 2 millimeters, yeah. Well, I think it is 2. But if you have to adjust it more than that, then the sensor itself needs adjusting. But it does work out. But the idea is to get this sort of pattern. And you can see why, because this one will not stick very well. This one will give you a much greater elephant's foot. Incidentally, on the elephant's foot you get on the first layer, one of the secrets I do there is if I'm producing something like that box and I don't want the elephant's foot, then at the very bottom of the box I'll put a 0.1 or 0.2 millimeter small chamfer. So then any elephant's foot is within that chamfer, if you follow me, rather than creating something big. On the box it doesn't matter, but I found it mattered on the axles that I'd done for the coaches, on the hangers, because the gaps were so small, the effect of the elephant's foot sort of filled in the gap. So by putting a slight chamfer on that side that faces the plate, you can overcome that.